Good evening. So I'm Convolutional presenting BotanyBuddy, AI-enabled precision plant nursery management for multi-crop disease classification and phenology aware age estimation is our paper. Research team. So I will present the paper. So let's move on. So here is the main sections that we will be talk around this and also the future direction of the BotanyBuddy will be considered in here. So as the introduction, I will say this BotanyBuddy, why we selected to do this the research. Basically, the rise of the AI and the model imaging makes the precision nursery management feasible. The precision agriculture itself is a new pathway for the future that is being enabled with AI with agriculture. So the research interested because of the manual visual checks are labor intensive and inconsistent during the peak demand. We need to provide a solution for that. So this is one of the particular reason that we just introducing the BotanyBuddy, and also the customers actually like to find about the age of the particular plant from a capture of a photo. That's the other research interest that we've been considered, and also the data, the visual data, the images that is being collected for the crops itself, it's limited. So we wanted to cover this section, so that's why we proposed BotanyBuddy in this research itself. The aim is, what is BotanyBuddy? It's actually build a unified production ready AI system that is enable precision nursery management, delivering multi-crop disease classification and phenology aware plant age estimation. That two AI models itself working simultaneously, that guiding care guidance for the staff of the nursery and also the customers who just getting benefited from it. So what are the objectives? One is creating a disease classifier using a deep learning model, especially for the crops that we selected, and design an age estimation pipeline that is uses with CNN classification model and also YOLO model object detection system, and implement a workable application. It's been used by both from the customers and also staff itself. So when we're talking about the literature reviews, so we selected the recent studies that we worked on. From here we saw one of the particular highlighted research is bell crop, that is been implemented a bell crop data set for diseases, and they used a CNN model, and it provided more than CNN is efficient net model, like a transformer model, around more than 93% accuracy. That is really good result. And also the research implementation used transfer learning to curate the paper images for identify the diseases, and also the vision transformer model that is done by Ahmed. It provided more than 97% accuracy, and ImageNet pre-training model that has been used to identify the varieties, the diseases of mangoes itself, and also Durian leaf disease CNN application that is being done in this year. It showed more than 90% of accuracy using efficient net model for disease classification, and also the grow more model that is been selected to get the images from different angles of a crop itself, and also from that identify phenotypically achieving how much leaves it is been that is being produced during the production, like harvesting session, and to identify the height and also the leaves itself, how much leaves been captured in here. And also the Anthurium expert model that is been done in 2021 also provide a disease classification model, and identify the leaves, how many leaves from object detection model in this application. So these are the most significant the researches that we gone through to identify the research gap of why we just making BotanyBuddy itself. So what is the uniqueness of the BotanyBuddy? One is dual head architecture, that is adapting phenology fusing with CNN for age estimation with YOLO model to counting branches and leaves, and data and robustness strategy we use in transfer learning and strong augmentation. And also we just wanted to just work with to reduce the class imbalances. The practical deployment is using single web application, and also giving the customers to work with that application to make the the nursery system more accurate and easily identify the faults of the plants itself. So this is the methodology itself. As you can see, we use dual AI pipeline. First one is for age prediction module and also one is for disease classification module. Both these models working simultaneously together and integrated to a web application to provide the output itself. So for the scope, we selected 4 crops that is been highly demanded for. One is for Anthurium, it's for flower industry, and for the florets itself. So mango and bell pepper, those Durian are like vegetables and fruits that is been commercially high demanded, and we selected these crops based on the demand of the customers itself. For the pre-processing, we use color normalization, optional background masking for highly clustered frames. The data is being collected. One is from that is been implemented from previous studies. We got that data from themselves, and also they make custom data set going to nurseries. These are the 2 nurseries we have to give the courtesy for them, that is help to capture the images from their nursery itself. And also balancing and quality assurance, we got expertise review, so especially botanical expertise that we've been selected, and the optional background masking to just clear about the noises of the images that we've been got. And the data split's been done for make sure that the images, the models that we're making, not doing overfitting problems. So for the disease classification, these are the 4 plants we selected, and this is the diseases for the images that is been overall got. And for mango, it has 4 diseases, and other 3 plants having 3 diseases respectively based on the most common diseases we selected, and we just train the models according to those. And also for dataset collection, for around 450, 500 for each plants for do the analysis. And also the age estimation, we made 3 classes for each plants, which is young, medium and mature. And for these 4 plants, their growth rate is different, so we just got the botanical expertise to classify how the classes has to be classified based on their expertise. So based on their expertise, this is the images that we've been classified and segregated to make our model work on. So these are the machine learning models that we selected for disease classification. First one is VGG19, because it's a baseline as transparent model that is been highly used in previous studies and also provide high accuracy. And also ResNet 50, a robust deeper features that is been identified from this model. And efficient B7 is also provide upper bound of CNN performance, have providing high accuracy. In past 2 researches that have been highlighted before, it provide a high accuracy. And also vision transformer model. So for the age prediction, we just use direct regression CNN, which is a vision net model trained for identify the MSC, like to mean square error, to identify the 3 classes that we've been selected. Why we deploy this classification to few the extreme errors and also identify the midpoint of the age range is usually operationally sufficient for the care plans. The regression backbone is made from ResNet 34. The age model uses leaf count, branch count, and the particular plant itself to do the regression itself. And for the leaf, branch, and counting, we use object detection model, which is YOLO VE8, that is been identified, been used, and it provided like a good accuracy. The pepper and Anthurium provide high regression around 0.9, because the strong link between the age and also the leaf having strong linkage within. But mango and Durian, due to their growth rate, it having some little bit weak relation, but it's sufficient enough to make the model predict good results. And also the phenology age estimation, this is the novelty of the application, captures the global morphology, and YOLO model explicitly trade the cues of human rely on, like basically the humans identified, to reduce the outliers. So this is the best performance for the disease classification, provide efficient net B7 around more for each plants itself provided more than 92 to 95% accuracy, which is high accuracy. And the operation result, BotonyBuddy hits more than 90% of the accuracy based on more than 3 out of 3 plants, and it is a good promising result that we just identified. And for the plant age prediction, the bell pepper that is been customarily made from ourselves provided high accuracy, and because the data set is vastly diverse, and the mean absolute error is around 4%, which is a good promising result for bell pepper itself. For the mango, durian, Anthurium, MA is kind of around 15 to 20, but it's a promising result. The observation, due to the plant's variation growth, it will differ because it gives a different kind of results. But we've been able to fine tune it and make the error being minimized, which is like a good like a good strategy for our system to be more accurate. And this is the object detection results after doing 100 epochs for each plant itself. Provide a good results. It will converge, not making any overfitting, which is like our work is been provided success in this result. So you can see this some kind of demonstration how the leaf bean detection from our YOLO model that we been built. For durian, this is how the confidence for each leaf that is being detected from our system, you can see. And for the higher MAE for durian, because of the complexity of the plant and the plant leaves and how it's been grow on the plant itself. So the test setup is around 200 H label images, been all unseen during the training. The overall performance around MAE like around 1.8 weeks, that is been as a plant itself, it's like a good result, to be honest. And the age group accuracy around 88%, which is like a good result, because this is our attempt to show that it can be with computer vision and also the object detection can be used to identify the age of a particular plant from these two hybrid version. And this is the workflow of the BotonyBuddy, the manual inspection. First, the nursery staff, they do manual inspection, and also we just made a QR code scanning to get the feedback from the customer, the image upload, the AI analysis, the two AI model that is being implemented in here, the care instruction. After that, the disease been identified. Our BotonyBuddy, it will show what are the symptoms and what you have to do to make it reduce, and also AI driven guidance being given. So this is the overall application overview. You can see the BotonyBuddy and how it's been disease been analyzed. The main takeaway of the system is bridging gap of manual inspection with BotonyBuddy, it giving real-time insight, like from a single image upload, it make to the when the image is being given, the particular machine learning model just go through the image and predict if there's a disease or not, and also provide the phenology analysis. And the high accuracy module of the disease detection, one of the key takeaway on here. And also the practical reliable age estimation model being selected because the hybrid vision itself provide more than 12-day MAE and sufficient for care schedules for inventory planning as well. And the limitation of our BotonyBuddy is non-exhaustive clauses, because we are limited with the data set, so we have to minimize that minimize for the diseases that is been that is not common that well. But if we just get the data set itself, we can improve the model and make sure more classes being classified. And the data set drift, one of the main another key limitation, because the nursery condition evolved, lighting and also the noise has been added. There were some challenges, but with like a more data set that is been captured, we can also work on that as well. And the data scarcity and the adaptation. As the future direction, expand disease coverage, like introducing new classes and getting more data set from there. Temporal growth modeling, and for strong age prediction, like just using multimodal and temporal model, and also integrating IoT and decision support system for this for our BotanyBuddy will provide a more accurate and more improved application that is can be identify diseases and also predict the age. So thank you very much for your this opportunity, and I really hope that you just get a good idea of our research that is being done. Thank you very much. Have a pleasant day.